my opinion, what we are doing today, what you are doing today is exactly that. It's people from all over the world with a desire to do something positive and to make and to have a global technology that is there to face the challenges of our time. So you have in front of you for this day, I hope that you will have the desire to act, to do something positive and to share. And this is all that I can wish for you. And there is no best place, there is no better place to do that than the LF energy. So I wish you all a very fruitful workshop, meeting, and a good job. Bye.
Thank you, Gabriel. Really appreciate it.
Hi, good morning, good afternoon, good evening. I'm really excited to be part of this journey and be part of this first virtual LFA event this year. Today, me and Benoit will give you a short overview of the functional architecture that we have working together on for the last year. But before we dive into the details, let's introduce ourselves shortly. I'm Jonathan Bogart, Solution Architect at Alliander, where I'm responsible for several digitalization projects in the area of system operations. Also, I'm one of the leading persons behind the open source program office at Alliander. And for those who don't know Alliander is one of the DSOs in the Netherlands. And I'm here together with Benoit. Benoit, can you also shortly introduce yourself?
Sure. Hi, everybody. My name is Benoit Janson. I work for RTE. So RTE, the French transmission system operator, like Gabriel Barre, actually, you just heard. And I am an enterprise architect, and I am working for the open source office of RTE and ensuring that we can have collaboration with the open source community. And it's really a pleasure to be with you today.
Thank you, Benoit. So when I was preparing this slide deck for today, I came across this quote from one of the pioneers of what's now called modern architecture. To create an architecture is to put in order, and put what in order? Functions and objects. And that is also exactly what we tried to achieve with the LFA functional architecture. When we started in the summer last year, we set a mission for ourselves. To achieve our 2050 climate and energy goals, we as LFA Energy have joined together to create a common functional architecture, defining a fit for the future grid and creating common understanding of the required functional capabilities. And this was the first step in our journey to create the functional architecture that we have today. Let me talk more about this journey. So we started with a small working group consisting of me, Benoit, some other colleagues of us from RTE and Alliander, and also some colleagues from Tennet, a large TSO in the Netherlands. And together with this small working group, we worked intensively together to create the first draft of the functional architecture that we presented at the LFA Summit in Paris, where we retrieved very many feedbacks, both very positive. And it led to new members joining us in the beginning of this year. One of the members was Sunrun and another member was MHP. And together with these new members, we worked intensively together in a few sprints to further improve the functional architecture, and especially to include the aggregated perspective in the functional architecture. And also we created a taxonomy. And you could really see as a glossary of the functional architecture that helps to define a common understanding of each of the objects and functions in the functional architecture of the functional architecture. And this really helped in discussing what we meant and creating common understanding. Also this spring, we tried to reorganize and redesign the functional architecture. However, the new design did not fully catch on, so for now we decided to go back to the original design. We will give it another try later this year. Also, we created a first draft of the Elevate landscape, energy landscape, which Bama will talk more about later in this presentation. And that brings us to today. Will we give an update to you all on the Elevate energy functional architecture that we have today. The Elevate energy functional architecture defines the fit for a future grid that we have in mind. And the architecture consists of 5 main blocks, also called categories, that together represent the grid of the future. In the top left, we have customer market. It contains all functional capabilities related to the customer and to the interaction with markets and other third parties. In the top right corner, we have system management. That contains all functional capabilities relating to managing the physical flow and balance of the power system. In the bottom right corner, we have asset management with all functional capabilities related to managing your assets. In the bottom left corner, we have acquisition and control with all functional capabilities related to monitoring and control your assets in your grid. And in the middle, we have a special category named shared. In this category, we got all functional capabilities that are required by each of the other categories. And this is only the first level of the functional architecture. It goes 2 levels deeper, which I think will help to clarify. Each category also contains subcategories. And these subcategories represent the main function capabilities of that category. For example, in customer market, we have the subcategory market platform gateway that represents all functions that are related to allowing energy market participants to retrieve and provide market information and engagements. In system management, we have forecasting that represents functions related to forecast that can both span to long terms, but also to a few minute ahead timeframes. In the category asset management, we have a subcategory outage management, for example, that's responsible and related to all functions to prepare and execute service calls related to planned and unplanned outages. In acquisition and control, we have also multiple subcategories, which one of them is Central Hub, that contains all functions related to collecting data and controlling equipments and nodes in the edge. Also in acquisition and control, we have a special subcategory, edge node control. And this contains all the shared functionalities that are required by each of the other nodes. And also shared contains several subcategories, such as security management, that's responsible for securing all systems and processes. And for each of these subcategories, we also defined the functional capabilities. For example, in customer market, the subcategory metering and compensation contains functions such as metering, compensation, and billing. Management, you have system control with functions such as remote operation, system automation, and in asset management, you have outage management with functional capabilities such as ticketing, outage programming and planning, customer impact analysis, assessment, and outage coordination. Acquisition and control. You have infrastructure management with capabilities such as remote equipment management, remote configuration management, and installation management. And in shared, you have, for example, security management with functional capabilities such as cybersecurity and privacy management. And together, these three levels form the functional architecture. And it really helped us in the last year to discuss LFA projects, use cases, and create a common understanding of the grid of the future. I've not said that this is yet the perfect view of the grid of the future, but it's the first step of defining a common view of the grid of the future. And next, Benoit will talk about how this helped us with positioning our LFA projects and use cases. The floor is yours, Benoit.
Okay, so move to the next slide, please. Okay, so as you can see with this functional architecture, it's possible now to put some of the projects that are already existing and that are already part of the Linux Foundation Energy. So that's a way for us to see how the landscape of the ecosystem of tools is covered by open source projects. So I don't want to discuss all that project. I don't know all of them very well, but as you can see, we have already some initiatives that covers part of this functional architecture. But lots of area remains empty, and that's also opportunity for us to see where we should invest in new softwares. One added value, one thing that we had in mind when we developed this functional architecture is to be as resilient as possible for the kind of companies that will need the softwares. Maybe that's not perfect yet, but we could discuss this architecture between system operators. So it was initially designed by TSO and DSO, but we could also discuss that with aggregators, and we think that with few changes, this could be possible also to use this kind of architecture for generation. And in that case, that's a tremendous opportunity for us to be able also to share some of the softwares that are developed for one kind of company to another, to be used in another company. So this become directly transverse software and standards for the energy domain as a whole. So maybe we can move to the next slide and talk about the Linux Foundation Energy landscape. So that's something, we took the inspiration from the CNCF landscape. You know, CNCF is another Linux Foundation domain, so for cloud native. And they developed this kind of landscape, putting on a single map all the software that are open source and also proprietary software. This enables to see what is actually the landscape. So the tool that is used for that landscape doesn't enable to have the previous presentation that we had, and we need to redesign a little bit where the boxes are, but so especially move on the right side the shared components, and have at the bottom the acquisition and control that are connected on top to the three main beneficiaries that are asset management, system management, and customer and market. So we already put in that landscape the software that we discussed. But we are open also for that landscape to put proprietary software, just to be able to compare the software, to have a single place in which you can see the open source software, and having a focus on the software that are part of the Linux Foundation. That's the one that covers 4 tiles at once. That's the one that are embedded into the Linux Foundation energy. The other ones are white when they are open source and gray when they are proprietary. That's a very interesting tool, and we'd like to enrich it and to be able to use it. Let's move to the next slide and to talk about the next step. So, so that's the attempt that we have. That's the new organization, the redesigning of the functional architecture. And we'd like to now to be able, it's been translated to the LF energy landscape. And now what we intend to have is to fill in it with as much as possible of software. Personally, I could use a CNCF landscape for our own need in RT, just to be able to find out what are the best software to cover the needs we had for IT supervision. And it was very, very useful. And so I really trust that this kind of tool is of high interest for to enable people to identify the right tools. And that's also a good way to promote the open source movement, and especially the one led by the Linux Foundation Energy. So move to the next slide. Yes, we want you actually to be on board of this process, and probably suggest to add other component into the functional architecture, into the landscape. But we also need you to help us to strengthen this functional architecture, to add your own standpoint in it, to refine the wording of the definition we have in the taxonomy. So thank you for listening, and I hope that we could discuss that with you soon. If you're interested in contributing, please register into the architecture list. And you can send email to that list, and or directly to Jonas or myself. Have a tremendous time in that seminary.
Thank you so much. I really appreciate the work that you all have been leading forth. So now we are going to walk through the various different tracks. And I think that Naomi, you have an order that you want folks to talk in.
Correct. Eric, the floor is yours.
Also, just one thing, in the chat, I'm putting in access to where the LF Energy landscape is, where you can find kind of an overview document that has about LF Energy and also the functional architecture, and a spreadsheet where you can add additional software to be put into the landscape, and then also a link to the taxonomy. So there's quite a bit of documents in the chat. And please let me know if you are having any problems whatsoever accessing them. You can use the chat window to communicate. Thanks.
So am I on?
You are.
Indeed.
Good
Hi,
morning.
Eric.
Hi. Good morning, good afternoon, good evening. I'm very impressed that you all joined this early and this late in the evening. I'm happy you joined. We, LFE, Sander Janssen of Alliander, which is a distribution system operator in the Netherlands, and I, Erik Houmes of Tenet, which is TSO in the Netherlands, would like to invite you to our data architecture stream. As we believe that understanding each other is a very fundamental part of the realization of the digitalization of the energy transition. And that being then the fundamental part of realizing the decarbonization and distributed decentralization topics of the energy transition. We've set up an interactive and collaborative session for you to show you the why and the what, and also the how of data architecture in open source projects. Sander Janssen of Alliander is going to show you their journey of harmonization of semantics and interoperability, both internally in their company and within the Dutch integration of processes. Quite a lot of our businesses of today think that interoperability is an IT party, just a technical thing, while it is first of all understanding each other by choosing and using languages that businesses understand, that companies understand, that you and I understand. And so we have to agree on those languages first. And then it's a technical party to realize that. And we will show you what we have done already as guidelines and frameworks to guide open source projects within LFE. And we closely work together, of course, with the functional and technical architecture streams to do that last months. We would like to, of course, have a very open conversation with you, to involve you, to ask you what you think is important, what you see as the biggest challenge, and what you see as issues for the next years to come. So on the short term, but also on the midterm and on the long term for LFE and data architecture stream to solve, but also in general, of course, the applications and the technical architecture in the LFE community. Finally, we'd like you to invite you to contribute to helping the data architecture further, solving interoperability challenges within the energy transition. So I would all invite you to join the data architecture stream in a couple of minutes. Thank you.
Thank you, Erik. Thank you, Sander.
Good afternoon, Bart Luik speaking of Alliander. Together with Florent Carli of RTE, we will present to you the LF Energy Security Framework, where we'll have an interactive session where we are on the job, on the spot, doing for a very interesting use case. So the Grid Exchange Fabric, we will perform a security analysis. We'll do a threat analysis and also figure out which countermeasures are applicable. We will do that just interactive, so everybody could think of the scope, its threats, and also how we could solve and mitigate the threats. The Grid Exchange platform is a very interesting use case, very important also for the Linux Foundation Energy, which allows you to monitor and control hardware in a public space. And it's also including switching on and switching off streetlights. So we'll have that as a practical use case for identifying the security scope, a risk analysis, and figuring out which countermeasures are applicable. Furthermore, we will have a special interest in also the CII's best practice batch program, which can help us to develop in a secure way. So we'll have a special insight on that. So David Wheeler will present the batch program, and also we will figure out how that can work for this use case. So hopefully you would like to join. Interactively, we'll all work on our risk analysis and work on the countermeasures. So hopefully you would like to join. See you soon.
What Bart was referencing, and I think I just put it into the chat window, is the Core Infrastructure Initiative at the Linux Foundation. I just put that link in so that you see what it is, and it's a badging process to ensure security, and that is kind of one of the next steps that we're doing, and that's what Bart was referencing.
Thank you so much.
Okay, then hello from my side, also Sven Leis. I'm from MHP, and I will invite you to one of the newest initiatives, so the infrastructure part, where we want to focus actually in a completely open interactive workshop together with Jeffro on how to design and define capabilities of the IT infrastructure under it. So in terms of security, in terms of interoperability, so that we have actually the word cloud, what is, I think in the energy sector, not completely used currently, so that we have it on the table and we can actually define something new where we set actually in this workshops the starting point for something big where we can have the infrastructure for running all the services what will be developed inside of the Linux Foundation.
Thank you, Sven. Very excited that this track is happening.
Hey, so we'll have also a track on asset monitoring and predictive maintenance. So this track will be into breakout session. The last one will be to build the synthesis afterwards. So the first breakout session will focus mainly on asset monitoring based on the Plasma project. That is an RTE project that is not yet open, an open source one. But we want to open it as soon as possible. It's an open platform for asset management, and we will invite you into a collaborative work during this session, and invite you to challenge the architecture that we designed to meet the objective of the Plasma project for asset monitoring. And a second time will be also regarding what are your recommendations as a community founder of open source to help us opening the source code of Plasma to be able to ease your onboarding into the project. The second breakout session will be more business oriented from the industrial perspective. It's how to transition from preventive to predictive maintenance and how open source can support this transition. And that's why we're designing this Plasma project that will be the seed that will grow and be able to embed a lot of a suite of products. And we'd like to invite you to understand what are the implications of that transition, and then to work together in how to leverage open source collaboration to develop the various products that are required to support that transition based on Plasma. And you may have a lot of ideas. We're very interested in that, and we really want to open the door of collaboration. Nothing is done yet on our side, and that's the right time for us to be able to build from the ground up a community that will grow and be able to cover all that ecosystem of the maintenance. Thank you.
Thank you, Benoit. This is very exciting. I'm really happy that people are going to get to see Plasma. It's an incredible example of bringing together the various different parts of open source from many different foundations, not just the Linux Foundation. You guys have done a great job.
Hello, this is Mithil. I hope you can hear me.
Yep, you sound great.
Okay. Thank you for giving this opportunity. Hello, everyone. This is a COMPASS. It stands for Configuration Modules for Power Industry Automation System. So what we are really doing in this events for breakout sessions, we are breaking out into 2 breakout sessions. One, we would be, objective to develop open source software platform for configuration of acquisition and control devices in a digital substation environment. So as Shuli mentioned, digitization is a heart of this activity. So we really want to utilize how do we configure devices interoperably such a way that multiple users, multiple vendors in this ecosystem of devices can be configured holistically with top-down approach. And we are utilizing to further enable interoperability through international standards such as IEC 650 system configuration language, and adopting those as a configuration modules to develop open source modules. And at this stage, we would be during the breakout session developing use cases. That so as a user, as a vendor, as a developer, how would you see utilization of this configuration top-down approach? And second, which is very important, the technology selection. So we would be discussing and really looking forward to broader participation with the open source experience people, be able to configure this type of devices, especially with XML language. I want to mention that if you have any experience with XML or related technology such as Java, JavaScripts, we really need you in these breakout sessions. And please come and share your experience, your benefits, challenges that you face for such type of configuration module development. Looking forward to seeing you, many of you in that session. Thank you.
Thank you, Mittal. This is a great project, Compass. We launched it a couple of weeks ago. It's a tremendous group from RTE, Alliander, GE, National Grid, Schneider Electric. So I thank all of your participation. It's the first project in the digital substation automation kind of umbrella. And so please join. We're really right at the beginning. Thanks so much, Mittal. Very excited about this.
Hi. Good morning. It's Juanjo. Good morning, good evening, good afternoon, depending on which part of the world. I'm Juanjo Hierro, Chief Technology Officer of the Fireware Foundation. And together with Gianluca Lianese, I'm going to chair this breakout session, which we title as Digital Twin breakout session. Well, the Digital Twin Working Group was created, bringing together a number of organizations that were willing to collaborate and find projects where to collaborate around an architectural concept, technical architectural concept, which was that of representing the assets, the real world through digital twins, and develop the architecture of systems and the way systems can be integrated, gravitating that architecture around the concept of digital twin. So during the breakout session, we will explain to you what have been the findings and results of the discussion so far, what kind of initiatives are in place towards the development of the standards and this approach regarding digital twin representation. And one of the objectives of these breakout session is that of identifying projects and people who wish to collaborate towards creating a common set of open source projects, systems, components that can be put together under the umbrella of Linux Foundation Energy, gravitating around this concept. By digital twin, we mean a way to represent real and digital world objects that are characterized by properties describing the context that is relevant to applications. And we leverage on this digital twin representation to bring support to both the architecture design of new generation smart energy systems, but also the way different systems within a large organization like a grid operator can really integrate together to support the overall operations of the organization. So this is going to be an open interactive session where we also have managed very recently to bring on board different people that were doing things already in the smart energy sector around these concepts. They are going to come and share their experience, and we will also carry out an open discussion towards identification of what could be the next steps, the very next concrete next steps towards creating a community of projects around this vision.
Thank you very, very much, Juanjo. This is great that you guys are doing this.
Good morning. This is Tef Reed from Sunrun in the United States. I'm here to talk about our VPP microgrids project. So we want to invite you to join the VPP microgrid project. You're going to, in that session, see two different sessions, one on microgrid control and one on interactions of virtual power plants with microgrids. We had planned a third session. We probably will talk some about transactive energy, but we didn't get a quorum for that session. We are planning on having this be use cases built out using a standard 4-level framework. And we invite you please to come join us in room 7 and join Gabor from Vanderbilt University, Ken Delaney from the Freedom Center at North Carolina State, and then myself and Greg Thompson coming from Sunrun in the United States. Thank you.
Thank you, Tef. Really appreciate it. This is great. We're going to transition from being in this room, and the way that you do it is that you leave the Zoom, you go back to the Quico chat, and you can enter into the other rooms. I think that there may be a few questions. Jeffro, is there anything that you wanted to answer while everyone is together? And if folks have questions, don't want to take us too far in, off schedule, but do want to make sure that everyone is moving along and comfortable with where we are.
Yes, I just posted the address to join Slack it's in the chat window on Zoom. You can also get to it in Kiko chat by clicking the network tab in the general room.
Great. Also in Quico chat, if you go back to that tab, there's a tutorial video. If you have any questions, there's networking, and there's a tab called Who Are You that you can come in and you can leave little tabs. What we've done is that we have created sort of, breakouts, a little bit of a break, breakouts, a little bit of a break. I know that it's hard for everybody to spend, just an enormous amount of time online. So we give you a few minutes in between so that you can stand up, get something to drink, stretch, come back. Any other questions? David Wheeler, did you want to say something?
Thanks. Nothing specific, but it was mentioned earlier, this CII best practices badge, and in the chat, I put a link to the best practices badge. Basically, it's if you run an open source project and you want to make, increase the likelihood that you're producing secure software, we've got a checklist. Go there, start the process, and it will give you a hand.
Great. Thank you. we will, I think the security track probably will talk about that. David will go into more detail. And then when we come all back together again in a few hours, we'll have an ability to really cross-pollinate between the tracks and really begin to see if we can create some next steps. Where we want to go with this is, really looking at our, where we want to be at the end of this year, and what our plans are for 2021. So thank you very much. Yes, the recordings will be available. And I think that we're going to start the breakout sessions at 5 after the hour. So you have a couple of minutes just to transition, but feel free to go to the breakout rooms and, folks can chat, get to know each other as we're getting ready to start. Okay, thank you very much. This is exciting. I'm really happy everybody is here. Everybody head to your tracks. Thank you very much.